Welcome to the Good Data Podcast. I'm your host, Drew Farnsworth. Today on the program we have Owen Osborn, CEO of Critter and Guitari. Owen founded the company with Chris Kucinski in 2007, and they've been building avant-garde musical instruments ever since. Their creations have been used by Taylor Swift, Bon Iver, The Flaming Lips, Magnetic Fields, and OK Go, and dozens of others. They have a collaboration with Jack White and Third Man Records to produce custom synths and amplifiers. They're known for allowing just about anybody to create music just by pressing a few buttons because they have devised algorithms that will build music with very little input from the user. I feel very lucky to have sat down with Owen. Before we get into our interview, I'd like to give you a quick sample of a major label song that used the pocket piano, one of his devices. This is End Love by OK Go. You'll be able to hear in the background this bleeping arpeggiation. That's the pocket piano. Before we really got into the interview, I sat down with Owen and played around with some of their newest instruments. One called the organelle, which is literally a Linux computer inside a piano.
The way I like to do it is you can actually plug an HDMI monitor into the organelle.
Oh, yeah.
And do it that way. That's just a synthesizer.
He just presses a couple of buttons and suddenly an algorithm literally generates a song. And then Owen changes the program, and suddenly he's made the organelle into a drum machine that very quickly sequences some beats.
But then you can put things on like every 7 beats. And then
So how often do you just kind of sit and make noises?
I get into phases where I do it kind of all day long, but then I don't do it for a while.
Every once in a while, Owen would interject some musical knowledge and mix it in with some computer science.
So this is one of the classic patches that, and it's a good example of something that would be hard to do. Like an AI wouldn't generate this easily.
And in a few minutes, we had this complicated rhythm that feels like it would be at home at an EDM show. You're going to hear a lot about the mad science that goes into these instruments, and the biggest reason that I wanted Owen to be on this show specifically is that he is such a proponent of open source software and hardware. His source code is available online, and a lot of his hardware designs are available too. And that's such a contrast to most of the companies that I'm used to working with. Most of us want to control our data and keep this tight grip on everything. In this episode, I'd like to show the bohemian side of data and how that sharing really opens up so much creativity and opportunity. Let's go. Owen? Thank you for coming on the show. I know this is kind of part of our What is Data series about like what actually is going on inside of hard drives and computation that is actually important. So
Cool.
I wanted to talk to you because you have some of like the funkiest designs for synthesizers and things like that I've ever seen. So Critter and Guitari is a company that you started 10 years ago?
That's about right, yeah.
Yeah, that you make synthesizers and other sound and video products that have to do with music.
Uh-huh.
And you've sold them over the years to, you had a deal with Jack White, and they've been sold to Taylor Swift and like Bon Iver, and I think the Flaming Lips have all used this stuff. Yeah. And then the reason I think it's such a big deal is because there's kind of an algorithmic component to the music production, right?
Yeah.
It's like you have arpeggiators and things like that kind of make music without having to really do anything.
Exactly.
Yeah. So how did you learn how to do that? Like you started at Skidmore, right? Working and learning about music production or electronic music.
Yeah, electronic music, and I was studying physics at the time and music at the same time. And most early on, it was just building instruments, that made sound. So I was interested in the physical mechanics of an instrument and how it could be altered or designed in a way to produce such and such a sound. Well, mostly making like traditional instruments like guitars and banjos and.
Right, because you made a banjo out of a cigar box and things like that.
Yeah, exactly. Cigar box banjos and these kinds of things. I don't know if they're the most scientific things, but I'd always been interested in electronics. In fact, I before I got into building acoustic instruments, I'd been really into electronics when I was pretty young and wiring things up and taking things apart. And then it wasn't until later where I started to get back into electronics, and I realized that electronics was really the way to go if you're trying to build an instrument that can do so much more musically than maybe you yourself are capable of. And it might have been after years of trying to learn an instrument and kind of being frustrated at getting good at music and playing music myself that, I went back and said, oh, well, maybe we could design some circuits that did some of this for us, and then we wouldn't have to learn so much of it.
Well, so that one of your early projects that I know about, not that I know everything about, but you made music generation system that had to do with cellular automata and like Conway's Game of Life kind of thing.
Yeah.
Is that right? So first, what is Conway's Game of Life and what are cellular automata, and how does that possibly get you into making music? Because it's like crazy to me that you put those two things together and it like became something.
Yeah, it was when I started using computers more, which is really just an extension of electronics on a bigger scale.
Yeah.
Being able to compute things, that I realized there's all these possibilities for linking crazy algorithms and programs and ideas like the Conway's Game of Life into music, and you can do it pretty easily.
Yeah.
So for instance, with the cellular automata stuff, it's this fairly simple idea where you have these cells that live or die based on sets of conditions. And you start off with an initial set of conditions, and then you apply these rules that govern whether or not cells live or die based on the cells nearby them and whether or not they're alive or dead. Right. So it's sort of an ecological kind of idea, you can imagine a population of organisms kind of, if there are a lot of them all concentrated in one area, they're going to use up all the resources and start to die out.
Yeah.
So the idea with the cellular automata is you have these kinds of behaviors emerging from these very simple sets of rules.
Right. And Conway, way back in the day, he just put that into popular science or something, and as an idea of like, oh, actually really interesting behaviors can come out of really simple rules.
Yeah,
right?
He invented the game of life, which is essentially just a set of rules.
Yeah.
So if you just look at the a two-dimensional cellular automaton, it's really just a chessboard, this grid. It can extend for as long as you want, but it's just this grid of cells. And then you make up this set of rules that dictates whether a cell will live or die based on the cells around it. So I can't remember what the Game of Life rules are precisely, but it's something like, if three or more cells surrounding so you pick a cell. Well, you actually go in order. You do this to all the cells. But starting with the first one, you say, if there are three or more cells that are alive, I'm dead. If there's one or more cells alive, then I stay alive. And this kind of thing. Yeah.
And then if there's like two, then it doubles or something, like it becomes...
Or if there's two, it becomes, if it's dead, it becomes alive.
Right.
I mean, it can only be alive or dead. This is the simplicity of it. So the rules are, if there's so many surrounding, and there's only 8 surrounding each cell on a 2D grid, each square has 8 surrounding cells.
Right.
So it's really just 2 or 3 rules.
Options, yeah.
Yeah. And if you pick those rules right, those numbers, you can end up with these different scenarios. And the Conway's one is really interesting because if you start out with kind of a random alive and dead state and then you start running these rules, you see these crazy formations form and these really beautiful patterns that happen all over the board. And actually it's I think it was the Conway's Game of Life was proven to be Turing complete, which means that you can actually, inside of this cellular universe that's running these rules, you can actually build a machine that will execute any arbitrary instruction.
Right. Like if you had a complicated enough one, you could run Linux or something. It would be ridiculous to try and do that, but it would be possible.
No, and there's actually people that have done these simulations, because when Conway invented this, he could only do it by hand.
Yeah.
Or maybe he had rudimentary computers and you could do a few cells, 64 cells at a time or something. But you can go on YouTube and look up Game of Life Insanity or whatever. Just type in Game of Life Conway and you can you see these amazing images of these machines that people have built with the Conway's Game of Life. So the idea is if certain patterns of cells will form into these mechanisms that actually do things. So one is like this mechanism called a glider, which is it's sort of one cell and then diagonally there's one cell alive, and then on its diagonal there's another cell that's alive, and then on its diagonal and the three cells next to it you have these three more cells that are alive. So you have this little shape. Mm-hmm. But it turns out when you iterate that, apply the rules to this shape, it has the behavior of moving.
Right.
So it actually flies along the board. And you can fly this glider into things and destroy them. Right. But then you can actually build this mechanism called Gosper's glider gun. And this was invented by another mathematician, Gosper, which is this sort of weird combination of cells that are in this state. And they pulsate back and forth when you run the rules. And they spit out these gliders.
Yeah.
So you can build up a machine that's spitting out these gliders. And then these gliders are flying into things and actually doing things.
Right.
So it's pretty funny because the machine is a totally visual machine, and you can look on YouTube. This one person made it
trippy.
Like it's very trippy.
Yeah,
this Turing machine where it's literally thousands of these little gliders, and they're flying around and pulling things out, pulling instructions out of the machine and executing them. And it's you can simulate any other software with this, but
right. I mean,
it would be hard to do.
Right. The gliders kind of like can go on infinite, and then there's all these different patterns. Like there's little explosions that'll just be a starburst infinitely, and then other things that like if it interacts with a starburst, it'll create something else. And how does that turn into music? Because that's I mean, this is such a complicated framework, and then to take that and take the data out of it and make something that is actually musical is kind of interesting.
Yeah, I think it really grabbed us originally, the cellular automata.
Because so us is you and Chris.
Chris, yeah. I remember discovering Chris is the kind of other half of Critter and Guitari, and we'd been doing this instrument building together for a while.
Yeah,
and went deep on the kind of cellular automata stuff together. And I think what really grabbed us was the visual nature of it. There's all kinds of interesting things, algorithms to apply to music. A lot of them aren't visual. Right. Even the kind of machine learning type of stuff, AI type of stuff that I've been more interested in these days, it's not necessarily visual. It's a lot of numbers and equations and kind of lines of code and stuff. But the cellular automata is just immediately, from such a simple equation, a simple set of rules, you immediately have this amazing visual world. So to create music out of it, it's kind of gets to another part of what's interesting in the kind of world of Critter and Guitari, which is the question of what a sound looks like or what a picture sounds like. And there's really no right answer to that. And it's really fun to come up with little mappings of our own. So something like a cellular automata, it's actually pretty easy because you have these cells on a board, and you look at a piano or most other instruments and you have keys that play certain notes. So the obvious thing is just to have the cells, instead of lighting up on the screen, they're just turning notes on and off. And that works to a degree. But,
is that interesting enough?
Is that interesting enough? And a lot of the instruments that we make actually kind of combine the idea of this cellular automata or any other algorithm, combine that with another input from the human. So you might sort of pick a group of notes, and then the cellular automaton is responsible for sequencing those notes.
Right.
So you're kind of might be in control of the melody or a progression of harmony, but it will be building up, a complexity behind that,
right?
That you don't have to worry about. So that's a go-to for us, combining this kind of input, the human input, and it's sort of making a hybrid instrument, which is really what I was talking about in the beginning, having the computer do something that you don't have to practice, you don't have to practice or some counterpoint or arpeggios or anything. You just hold your hands down and let the computer choose all those notes.
Well, but you still are making music and you can add layers on top of that, but then you can just start with that kind of arpeggio that is interesting in itself, and then you can build.
Yeah,
right?
Exactly.
I remember when I first ever talked to you about this stuff, you had the pocket piano, which is probably, I don't know, the dimensions are like maybe it's 4 inches by a foot.
Yeah, a foot long, 3 or 4 inches wide.
And it has these awesome wooden keys that are very tactile and just are fun to push and have a real distinct look about them. Mm-hmm. And you started out making kits that people could build at home with the pocket piano, and then it had all this functionality that you built on top of that. So I want to even go back farther than that, because you said something that was really interesting where you were talking about making images into music. So you were part of this thing called Dear Raindrop. That was this artist collective that was really funky and out there. At one point, like, you had this installation that was a sphinx and taking images and turning it into music, and then turning the music back into images. And what was Dear Raindrop, and when did that start?
Yeah, that was this artist collective that was around probably, since the late 1990s or even before I was introduced to them. And these were friends of Chris Kucinski, who's I work at Critter and Guitari with now. And they were really into mixed media, immersive artwork. And it was really attractive to me because they had no distinction between making things out of sound or making things out of sculpture or any materials. It all just flowed together into this one kind of mess. Right. Which was really exciting to be a part of when I started working with them, because we could just make these machines that would just operate in this zone that was between visual art and music and performance art and video art and all, and kind of this intersection, which would be things that would eventually become sort of Critter and Guitari instruments. Started out as these installation pieces. Yeah. That we would hang on the wall in a gallery and people could come up and play with them. And from the beginning, we had these instruments that would synthesize sound from images, and things like these little color sensors that you could hold up to the artwork and it would make sounds, Yeah. And it had embedded in it this mapping of the sound, what the colors should sound like, right. These kind of things. And this was all wrapped up into the kind of single experience.
So it could be something really simple, like blue is 440 hertz, or it could be something like blue is drum machine and red is,
exactly.
Like
That's something we experimented with a lot. Yeah. It really became, that mapping became this like medium of itself. We realized in the beginning, I was always trying to figure out the perfect mapping from color to sound, but then I realized that was really the kind of palette, or that was the canvas on which you were kind of making this this artwork. It was like, how does the color sound? Like, there's not really a right answer to this. It's really up to us to figure out. So I remember I have a couple ones that were actually the colors were directly controlling frequencies, like you mentioned, and then some other ones where we would just play samples into them, and they would spit out the samples. So the sound was coming from the visuals, but it wasn't really a direct relationship. But it didn't really matter because we made the relationship.
If you have 3 sensors, one for each color, like RGB, you could make one do something, the other do something, or you could have like almost like a whole camera where it's like each individual pixel of the camera would be doing stuff. There's so many different options.
Right, there's so many different options. Yeah. A lot of the stuff we were doing earlier was just like the single pixel, just the red, green, blue value. But it was funny because we went up one time for this show in Winnipeg. We were getting interviewed on the national radio or something over there, and we had told the guy like, oh yeah, we have these color sensors to come by, check out these color sensors. And he's like, oh, I'll do a picture, we'll scan my picture and see what it sounds like. So we came by and scanned his picture, and it made all these crazy noises, but the kind of joke was, for me at least, it wasn't even, the sensor itself was broken. It wasn't even working. So it was just like, it wasn't even using the color values. It might have just been using maybe a little bit of an intensity value. It would be like just squinting through, like if you were just totally drunk and like looking into your beer glass.
Right.
Through at the world. Like that's all you could see. This is about how well the color sensor was working.
Right.
So I felt a little bit disappointed that it wasn't more accurate or something, but at the same time, I mean, that is what it is.
I mean, what can you do?
Color sensor.
Today's episode is brought to you by Green Lane Design. Green Lane has been designing, engineering, and building critical facilities for over 10 years, from small server rooms to major data centers for Fortune 100 companies. GLD is also expert at computational fluid dynamics simulation. Mouthful. That's computer simulations of airflow in data centers. If you would be interested, go to greenlanedesign.com. Click on contact and mention the podcast. Yeah, I mean, it's funny because you're kind of like in manufacturing too. So you have to do all this artistic and electrical engineering kind of work, but also you have to make sure that it lasts and works all the time. And when you're doing an artistic installation or something, you're basically soldering things together. And, now you've moved on from that and you're actually like doing manufacturing in China and things like that. But at the time, you like had your soldering iron for the actual installation, which must have been a nightmare sometimes.
Yeah, it was sort of always a nightmare, but it was the, it was what had to be done, I guess. It was the tools of the trade.
Yeah.
But it's not unlike what I'm doing now. I mean, I'm just looking at my desk right now, which is a total kind of mess of
That's true.
Wires and soldering iron, which I've been using. It's maybe more segmented or something, the work now, where I have to get out and solder, constantly.
So I see.
Even if I'm just fixing something,
I'm
not making something. I'm just trying to get something to work. But it's a little different because I'm trying to get it to work in such a way that we can just call it good and then produce, hundreds or thousands of them, and they'll all be working and continue working. So
you have a half dozen just regular circuit boards that are Critter and Guitari made, and then you have another half dozen Raspberry Pi boards, and then you have maybe another rapid prototyping board, and you got a lot of stuff.
It's sort of a mix.
Yeah. And then like a random mixer. It's very much like Mad Scientist. Okay, we got all these parts and they're all going to work together, and it's not exactly organized, but you know that there's some kind of order to it. It's very cool. We skipped over grad school. You went to Dartmouth for this specific program that was about music.
Oh yeah, it's a really cool little program.
Yeah.
And it's sort of a funny program because there's only 6 students there. And it's also at Dartmouth College, which is a pretty standard, more traditional school in terms of all the departments. I mean, it's, still a regular college, but it wouldn't be the place you would expect this weird electronic music program to be. And it was a small little program that's pretty unknown, and they have this little house that's sort of behind a couple of the dorm buildings there called Hallgarten Hall, and it was just filled with weird sounds and people making weird sounds, and it's really great. And you go there and you just hang out and kind of work on
sounds. When I think of what you do a lot of the time and what I've seen you do, it's a lot of it is not even so much when I'm watching you making music. It's about like screwing up knobs and making weird sounds, and then eventually that turns into music. These days, electronic music, a lot of it is made out of patches and things that aren't straight up instruments. They're some kind of weird oscillator that goes into another feedback loop that then turns into a cool instrument somehow. So that's kind of the cool thing about seeing your work, is that it's not straightforward. It's not like, boom, here we are at music. It's like seeing the very core underpinning of all that. It makes me think of when I was first talking to you and like years and years ago about music. You would kind of take me down rabbit holes of the math and stuff behind it, like all the way down to like talking about the Fourier transform and like the basic math of it. So I felt like I learned a lot from you about that kind of stuff. Can you just talk about how you take something like a sawtooth wave pattern and turn it into music?
Well, it'd be hard to answer that question in full because I feel like on one hand, I'm making music, but on the other hand, it's not really ending up in any kind of packaged form. These days, I think mostly it's that I'm making sounds or something for other people to assemble into music. In terms of the music that we normally think of as songs and kind of pieces, but there's when you go deep, like you mentioned, there's this similar nature about music, just as anything in nature. And, the sounds themselves have this internal structure that's very similar to the structure of a whole song or whatever. So I don't know, maybe they're sort of the same. But anyway, it would be a stretch for me to say I'm kind of like a composer or something,
But even just like making the sounds, like I remember one time I saw like the source code that you were working on, and it just said A equals 440 or something like that. So you had to go when you first started, you were going down to that like specific level of like the actual hertz of a given note and programming that in and then building on top of it.
Oh, sure. Yeah.
Yeah. So, and now you have like these incredibly complex patches that work through a Linux computer that's embedded into the circuit board, and it's gone leaps and bounds since that original time. But
it has in a way, but it also it's very much stayed true to that same kind of thing, but a lot of the technology we're looking at here, these kind of instruments that are running, that have these embedded computers, these ones happen to be running a computer music environment called PD or Pure Data. And this is the program you start up, and it's just a blank canvas, and it usually starts out with, oscillator 440 or something similar, So really everything is built on this core kind of low level building blocks, these oscillators and sample tables and these kinds of things. The difference now, I guess, is that you can still, inside the same machine, you can copy and paste these oscillators. So you can have hundreds of them or, thousands of samples at once. And that's where it really starts to get interesting, where you can build up these new functions that do all kinds of cool and crazy stuff.
That's the organelle, right? This
is the organelle, yeah.
And that's actually kind of crazy because it is a full-fledged embedded Linux computer that is also a little piano and a synthesizer and a sequencer, and you can do just about whatever you want with it, but it is all encased in this 3-inch by 1 foot little box, right?
Yeah. Mm-hmm.
It's very cool. And it, you can understand why people would get excited about it, because you can have this very portable thing that can do just about anything. Is that something that you knew would be valuable, or is it just something that you fell into because you started at that pocket piano and kept building stuff until it became the organelle?
No, it was something I'd kind of always wanted,
Yeah.
Because I used to do this when I started getting into electronics and then getting into computers. I was making a lot of music actually using these same software tools 10 or 15 even years ago. And it was frustrating at the time because I wanted to be able to embed these things into a physical instrument instead of having them kind of detached in this detached zone of programming on your desktop or whatever. So it was something that, I'd always wanted to be able to do, and it took a while to be able to do it, to have the technology shrink enough so that you could just put it inside of a little wooden box and have it do all this stuff. But it was kind of a dream, for a long time, to be able to have this instrument that could be repurposed and could evolve into something, that was different and different for depending on who's playing it and who wants to use it.
Not only is it a cool idea, but also the implementation of it is really cool, because there's a little screen on it that is very simple. It's like maybe a 5-line interface where there's mostly text. Mm-hmm. It's almost not taking you out of that feeling that it's still an instrument. It's not a computer.
Yeah. And I think actually a lot of that did evolve from the pocket piano. So it's not entirely, it wasn't like 15 years ago I set out to make an organelle.
Yeah.
I think, the pocket piano was sort of I'd gotten frustrated with the computer and just started programming these little smaller circuitry that would make up the pocket piano and all the other instruments we'd made since then. So it was sort of a combination of, it really was more, now that you mentioned that, more of a combination of the kind of where the pocket piano took the instruments, and then also, wanting to make something that was, repurposable, reprogrammable. Yeah. Because the organelle is very similar to the pocket piano. It takes what's strong about the pocket piano, which is the simplicity of the controls. There's not that many of them.
Yeah. It looks the same too.
It looks the same
There's
too.
Maybe like 4, what do you call them, dials?
Knobs.
Yeah, they're probably knobs. If you didn't see the little screen, you would think it was the same thing.
Right.
So you have like a real specific aesthetic. Like ever since the Deer Raindrop had this very funky, very bright colored rainbow patterns on everything. And it feels like you actually pulled a lot of that through the whole time. Like you've kept a lot of that, but you've updated the pieces behind it. And now you have like these anodized aluminum fronts and then like a wooden back. So the wooden back is there. Why did you keep the wooden piece of it? Like what was the reasoning behind not updating the whole thing to metal?
Right. Yeah. On some of the instruments, we actually have updated, the parts, and they're continuing to kind of evolve. And the wood buttons have been there the whole time as, the parts that are particularly fun to look at and, inviting. I've often used as the word that when you look at this object, you're like, oh, I want to play around with it. Instead of just looking at it and say, oh, that's a, toy piano or whatever.
Right.
Which it is, but this is a cool looking one with these wood buttons, so we better see what this thing does. So in a way, it's a challenge because often I'm like, oh, I'm going to just go do something a little bit different or totally different. But you end up falling back on, these little riffs or whatever, design tidbits like the wood buttons that just work really well.
It doesn't look like anything else that is out there in the market. Like there's a way in which it looks more organic. It's like this, like almost everything that you're talking about is this fusion of like the organic stuff and the computer stuff and the electronic stuff. And so that wooden button really, to me, seems to like pull that back.
Instruments were made out of wood, mostly all of them.
What you had the wood for a while to kind of create a better resonator? Was that true for a while, or was that?
Yeah. The Kaleido loops were entirely wood for a while.
Yeah.
And I mean, it does sound great. You can just bolt a speaker onto like a wood thing and it's going to always sound great, where it might not be the case with plastic or metal.
Right.
It'll sound cool in its own way, but the wood has a nice resonance to it.
Yeah.
So it is hard though to make a lot of things out of wood because it's slow to work with.
Right. Yeah, I mean, it's harder to manufacture and it's more expensive. And so it brings us to manufacturing. So you got started in this in a very like technical sort of like, designing your own circuit boards in Eagle and actually soldering things yourself and doing everything kind of yourself. And now you're at the point where you're really manufacturing things. And now you become like this company that is, in a lot of ways, just as much a manufacturing company as a design company.
Mm-hmm.
So what's that change been like business-wise? Is that a big difference?
It's never been an abrupt kind of change. And we still do things and build things very much the same way as we did when we just started out. It's just that we've taken one by one the things we used to do ourselves and kind of outsourced them to other businesses who do that more professionally. So the first pocket pianos were made entirely by hand. Yeah. The circuit boards we had made because those are hard to make by hand.
Yeah. Yeah, you're not getting like photo like resist. Printing circuit boards.
So those were always pretty affordable, easy to get, even in small quantities when we were starting. So we would get the circuit boards, but then we'd solder everything on, all the pieces on by hand, and then we would glue up the wood backs by hand. We would finish the wood buttons. We had found early on someone to turn them on. They had built a tool to do it on a lathe, but the first couple runs we had to paint them ourselves. And then one by one, it's like, oh, we could have them paint them, then we don't have to, and then we could have someone else assemble the circuit boards, and then we don't have to do that. And then eventually like they could also just buy the circuit boards and buy all the parts for us, so we don't even have to touch any of that. Right. But we still do that final step of putting everything together and testing it ourselves. So in a lot of ways, it's very much the same as it was. It's one by one, making it easier. But it's not like we've taken the step, which would be a totally different step, of having them made somewhere else where we didn't even see them. Yeah. So we're still very much like one of us. I mean, there's a few people now who work putting these together, but
Yeah.
someone in the business has touched every single key on every single instrument to make sure it's work.
That keeps the connection instead of having everything just in China being created. You actually still have that personal bodily connection where you can touch everything. For some reason, you were in Vice magazine. There was like a music section of Vice magazine.
Oh, right.
And they called you artisanal. Like you're an artisanal synthesizer maker.
Right.
I thought that was interesting, like because it was handmade stuff and because it was not exactly mass market, that somehow that was different. Is that something you intended to do, or was that just kind of like, yeah, well, that's just how we do it?
Yeah, I guess that's just, I didn't start out, thinking, I want an artisanal business.
Yeah, it's not like you're making cupcakes.
I guess it is artisanal. Artisanal is sort of handmade, small batch.
Kind of.
Boutique, that's the other word people use.
Yeah, there's definitely a handmade vibe, even if it's not soldering by hand in the studio.
I think a lot of it has just come from we've never thought about, do we want it to be a boutique or an artisanal or what have you. We just make things right. And then they come out like this.
This is what the other thing about your business that kind of floors me is that it never really seemed like you did any advertising. The videos that you would put out, you had some animations that were put out before you actually put out the Bolsa bass that were so funky and weird and just kind of trippy and wild colors. And I was wondering if something that you really thought about how you would market things or how you would put them out there in the world.
Yeah, I think it was mostly, we just viewed all these aspects of putting something out there and making something as an opportunity to do something fun or cool.
Yeah.
So, if we're putting a instrument out, it's got to have a video.
Yeah.
So it's an opportunity to come up with a cool and fun video to do. And usually a lot of those videos, like animations you mentioned, were made by our friend Devin Flynn. And it's an opportunity to work with someone like that. They're a super talented animator and just making something cool that we're all happy with. And we made some other videos, and a lot of these videos now we're making in house, which is fun too.
Right.
But we don't really think too much in like a marketing kind of way, or perhaps we do. We just haven't been trained in that kind of area. So it's mostly just we got to make a video to show how this thing works, to show what it is. So let's have fun doing that.
Even your marketing videos feel like an art piece in a way. Like, not everybody's, well, like a lot of times they're just like showcasing blurred bokeh images of the product. Whereas you guys actually put out something that is inarguably weird and also kind of fun. That just seems like such a different way to do it. And I feel like there's a lesson in there somewhere for marketers and things like that sometimes it's much better to do something honestly that is different and artistic than to like try and do something that is boring and straightforward. Yeah. Although sometimes like I shouldn't say that. Some of your videos are pretty straightforward. I don't mean that you're always like out there crazy, but
I think it's just kind of trying to have fun with them,
Yeah.
And a lot of the organelle now provides all these little opportunities for videos, because each patch that we come out with, and now we have a couple people working in house on these videos, and Chris does a lot of the direction of the videos and stuff, and our other guy Chris, we have a lot of Chris's in the company, putting the videos together and just really have gotten good at making these awesome demo videos that are really fun to watch and beautiful at the same time. Yeah, they're really well done. They're informative, but the production quality is really good. So not everybody who does that kind of stuff like puts that time and effort into making those tutorial videos like as good as they are. Yeah. I think there's a lot of parallels from the videos to the the actual physical instruments themselves. Right. It's a lot of the same kind of ideas of just wanting to make something really nice and keep it nice and keep it serious. Well, the other funny thing is that you specifically have kept everything open, and like for a long time you actually had kits that would make the instruments that you were selling so that people could make them at home, so that all the designs were kind of open source. But also now you have all these patches
And you're not like controlling the website that has those patches. The patches are just out there in the world, and you're just sharing them and showing people how to do it. So you're not holding on to that control. You're allowing everybody else to be the ones who take that control. So it's the customers and the users and the people who are actually doing it that have the control. And it's almost like you didn't try to make a GitHub for all that to put it all together and control how it's disseminated. You have it out there in the world, and everybody else is sort of taking control of it. So it seems like that's just kind of part of your ethos. Is that, the kind of open source mindset? Is that something that you're just a part of you?
I think so. I mean, just going back to the kind of the early days of when I started doing software, it seemed like the open source was just the way to do software.
Yeah.
And that's just seemed more obvious to me, and I think it's been proven, over the last 15 years that, even you see these large companies adopting all the open source technology, and now it's not really a question. I mean, you still have these businesses who do proprietary software. Well, I don't know much about businesses and proprietary software and this and that, but I do know that the open source stuff is really cool and it's really powerful, and it's powering like
90% of web servers,
90% of everything. So, so it definitely works, and it's definitely the way to go. But more specifically for a musical instrument kind of application, it's really cool because it allows people to share these musical ideas in software and riff off them and contribute to the evolution of or whatever of this instrument. So that was always a concept of the organelle. Was having this instrument that would be kind of like, all these people all over the place are contributing to it. It's sort of this living more. Yeah.
Is that where the name organelle came from? Like a organelle in a cell?
It did a little. Chris came up with the name, and I instantly knew that it was the perfect name because it's this kind of organism, and a little bit mysterious because who knows what an organelle is anyway.
So I'm not even sure. I just know it's I remember biology class.
Organelle, it's kind of organic, although no one likes that word to describe anything. But it's in there too, and then it's like an organ too, and an L, small organ. It's just the perfect name for it.
So, you have the sound stuff, but you also have video installations too. Isn't that one of your new products is a video product that takes sound and turns it into like images, right?
Yeah.
And you were doing that a long time ago with the Dear Raindrop stuff, but then you kind of took it to another level.
Yeah. So we have the newest version is sort of like the visual version of the organelle. It's this video synthesizer that takes audio input and also musical input over MIDI, which is, for drum machines and sequencers and keyboards all use this thing called MIDI, which enables them to communicate. So you can plug that into the machine and it'll visualize all of this information in different ways. So on the organelle, you have these patches that give the instrument different behaviors. And on the ETC, you have these things we call modes, and they are kind of analogous. They visualize the sound in different ways.
Right.
So everything from simple kind of, one-to-one relationships between the actual waveforms, the pressure of the sound, which is, the classic oscilloscope kind of patterns you've seen, to just really far out animations that you can also, the other thing about this, like the organelle, is it's open source and you can program your own modes. So, you can program a mode that just ignores the sound completely. It just does animations.
Right.
So that could be your visualizer, which is fine. But it's a lot of fun because you can program it to manipulate images and just make some really crazy visuals.
Have you seen it out there in the wild being used, like in situations?
Yeah, it's definitely used in situations, musical
situations. That was very specific on my part, but
for a variety of situations, it's in
like on stage or
parties and in stage. Yeah, people definitely use it on stage. Yeah. I mean, the video stuff is tricky because you got to patch it into all the systems that they have, and I feel like a lot of people use these software programs, VMDX or whatever it's called, to generate the stuff. Yeah. And, I think a lot of stages and big venues are kind of set up for this. It's a little bit more challenging than just having an instrument where you're like, oh, just, hook up the mic or whatever.
Right.
But people are definitely using it. I mean,
Yeah.
we've seen it projected in giant venues.
Yeah.
So it's definitely exciting and
Yeah, it's very cool.
Fun machine.
I remember doing like Winamp in like the late 90s and
yes,
really loving the visualizations that came along, that you could kind of program these weird things to go along with the music, and probably stared at that for a good number of hours.
It's really what it's just Winamp in a box. Yeah, I remember my neighbor was like, "Oh yeah, have you heard of Winamp?" I was like, "Yeah, it's pretty much what this is."
Yeah, but at the same time, you can change it and alter it, and there's more ability to make.
Yeah, and you could program your
customize.
own one. I guess you could do that in Winamp. You could kind of custom. You could kind of go deep. I remember people.
I never really tried, but yeah,
crazy. I just remember it must have been in college or something, and
I'm sure you could program your own.
What's he doing? He's doing Winamp. He's just like on his computer, just doing these Winamp visualizations.
The Napster and Winamp days.
Yeah.
So I mean that's an interesting thing too, because the cool thing about the ETC is that it's a box, that it's something that you can hold in your hand, whereas Winamp and all that kind of stuff is on the desktop or in the computer, and it doesn't feel as like personal and versatile, and it doesn't feel like an instrument. And also sort of with the organelle, like you could do all that stuff in Ableton, right? Ableton is like the I don't know if it's the de facto, but it's one of the more popular music sequencing programs out there, right? So do you ever think about like mixing and matching, or is it something that you do to kind of connect to Ableton or some of those desktop programs? Or
yeah, well, people are always connecting things up all kinds of ways, and MIDI, like I was mentioning, is a popular way to do that. And it's funny though, because actually not Ableton does, can certainly do all kinds of stuff, but PD or Pure Data, which is the software on the organelle that runs the patches, you can just run that on your computer. So you can literally run any of the patches the organelle are making, just on the computer.
Right.
But I think it does get back to this idea of having this box that's a little bit more focused in terms of its function.
Yeah.
So you sit down and you're like, I'm going to make music with this thing now, and I'm not going to mess around with Ableton. But it's a challenge because, the thing that makes it cool, the organelle cool, is this idea that it can run these different patches, which are really just sort of software apps.
Yeah.
So it quickly becomes a very computery kind of experience as soon as you start to like manage these patches and take them off and put them on, and you want to put different sounds in different ones, and then it becomes very much like a computer, the same problems you have with your computer.
Yeah.
So the challenge, I think, in making these types of instruments is keeping it true to the idea of playing music and not like these kind of file management problems we always talk about. These kind of computery kind of problems, that are really have, I think, always detracted. I think people who are serious about making music overcome these and they figure out their way to work with, but they've always been so distracting to me, that it's worth it to design your whole computer yourself and put it inside a box. That's easier than dealing with like trying to figure out what to name folders or something.
Yeah, well, I guess that's what got you here.
Yeah, so I just screw it. I'll just make my own computer.
So you actually designed the user interface, right, for the organelle to it's a very simple.
The idea was like, I kind of call it a jukebox for musical instruments. It's like a radio. I remember being in the car and just, I always look at the radio in the car, and a lot of them are bad and some of them are okay. Yeah. But I really like this one radio in this rental car I had where it's just a knob, and you were just like, you'd scan through the stations like a big menu. And then maybe you get to the top of the menu and there's just like the kind of system settings. Yeah. Or that might have been our idea anyway. So that you turn the organelle, it's just this big list of these patches, these apps. And then at the very top of the list is some system kind of configuration kind of stuff. But keeping it simple was like, that's what I was talking about. It was a key goal of the thing. Yeah. But since it's gotten more complicated and, it's crept into that zone of more computery stuff. We've had some awesome contributions from this guy, Mark Harris, who's a computer music software developer, and he actually rewrote a lot of the UI on the organelle.
Oh, I
it's
didn't realize.
Basically the same,
Yeah.
but he, because the UI itself is open source, so he improved upon it, and he made it so you could, you have subfolders so you could better organize stuff and really get into the kind of file management aspect of the thing.
Yeah.
Which is, it's important to be able to do that because people are used to thinking like that.
Yeah.
So it's, on the one hand, like, these are really important things that people, including myself, like, I use all the time. But the challenge is really sort of being careful about that stuff, that it doesn't turn into just a computer.
Well,
it's done in such a way that doesn't distract from the musical.
Because there's two parts of music. There's the creative part where you're building music and making new music and somehow like you're playing with things and trying to make a new song. And then there's also performing that song. So in some ways, the simpler user interface is great for just like playing around and making something weird and new and different. But then when you go to perform something, you have to do it real quick and sequentially so that okay, right, I'm going to go here. So it's almost like you can use the same actual physical instrument, but have two different interfaces to kind of jog both parts of your mind.
Yeah, I think that's a good way of putting the challenge.
Yeah.
And I think we've always come from the experimental side, usually just because we've, never have the opportunity to have an actual gig. Anyone would want to have us play. It was, it was mostly let's see how to design this thing in such a way that you can just bring up as much crazy stuff and kickstart as many musical ideas as quickly as possible.
Right.
But then, thinking about how to use it in performance is like a whole nother thing, and it does get kind of complicated, trying to do both of those.
Right. It's kind of what's nice about it being open source is that you can.
Yeah. It has been, and the same guy who made this interface, he made this great system where you can actually repatch the thing sort of on the device. You can actually string together. He modularized the patches so that you could string them together and make more complicated patches.
Oh, right.
On the device itself without having to, program it.
Sort of like, I mean, that's what you do in Ableton or those
right.
kind of programs.
Yeah, exactly. You say, I want to hook up this sequencer to this drum machine and this synthesizer, and then I'll run it all through this effect.
Right.
So he designed this thing so the organelle has these patches that do a sequencer and it does a drum machine and it does an effect, but it might not do them all at the same time. So he made these into actual like software modules inside Pure Data, and then built this kind of framework around it so you could actually, using the organelle itself, you could select sequencer, drum machine into effect and make these chains of things. So that is when it does start to become, a very powerful thing, more like an Ableton kind of thing. And also brings up a lot of questions of how do you use this in performance, because we got to be able to do that in the most efficient way.
Right.
But he solved a lot of those problems, so we're we've been working together on making it even better, because it's a very powerful idea to be able to.
Well, it's kind of like, what did you think when this guy suddenly you see online that you have like a new user interface for your own device?
Oh yeah, I was totally blown away. I mean, it was so awesome to be able to have this guy working on the stuff. It was just like
just because he really liked the product.
Yeah. And it was it was sort of a dream come true, because it's like we'd been doing this open source stuff for a while, but it wasn't until we really had to kind of built a whole organelle and built a kind of community and kind of hollowed out this space, and people started coming in, and a lot of people have made some awesome patches and stuff. So
what does the community look like? Like, what websites are the ones that really disseminate this?
Well, we have our website, which is we host an online forum, like a community forum, where people post questions and discussions and stuff. So that's where a lot of the kind of discussing happens. But then there's two sites. There's our site where we host the patches that come when you buy an organelle. It comes with a set of patches, the kind of so-called factory patches. And we host all those patches. There's about 50 or 100, maybe about 70 patches. and we host those. But then there's another patch site called Patch Storage, which is actually a project that launched about the same time as the Organelle, and that has many hundreds of patches that other people have made for the Organelle. It also hosts patches for other devices and other platforms, similar instruments to the Organelle, and also software-only patches. It's kind of so you go to Patch Storage and you can choose different platforms or devices, and one of them is the Organelle. So you go into the Organelle space, and there's all these patches by community members. So that's where people are able to upload their patches.
Okay,
so it's not controlled, by us. It's an open kind of.
Did you want to control it at all, or were you kind of happy to have somebody else do that?
I think we were happy. Yeah, I was thinking I would have to build our own.
Yeah.
But then right when we released the Organelle, they just released this thing and asked us if they wanted to, host the patches there. And, what I would have made is pretty much the same as what they had already made. So it was a natural fit.
Yeah.
Yeah. In terms of the other reason to have it yourself is to kind of be able to curate them and control them. But I think we decided, there needs to be a space where people can just share the stuff no matter whether it works or not, or no matter what. I guess the comparison is kind of like the Apple store versus maybe the Android store versus maybe, I don't even know anymore.
Just like download.com.
Linux, where you can just run any program.
Right.
But Apple is like, they're literally like, vetting the apps to make sure they're high enough quality.
Right.
And Android's a little bit more free. It's like they have a pretty strong kind of security. And well, I don't know anything about Android security. Just talking about this shit like I know what I'm talking about.
That's okay.
Anyway, the Android apps are a bit, I feel like there's not as much kind of... there's not a single kind of entity, or maybe there is. They're doing maybe security reviews, but anyway, the apps there's many more of them, and they're not as up to the same like high standards. That was an idea to make it kind of like Apple Computer, and kind of like people could submit apps and maybe even sell them. And but we were just like, no, that's not cool. That's just like, we'll let the community do that, because this is supposed to be a DIY kind of music project where people are creating stuff, and it's supposed to be as at the end of the day, I guess it's what is to say. Some people like these patches that just like might not even work, and they just are highly experimental, and you have to tweak the knobs, and maybe there's one little position where you get these amazing sounds out of them.
Yeah.
And we might say, oh, this thing's just broken, but someone else might say, oh, this thing is glorious. Well, so it's like more of an artistic question. So we decided early on, it was just like, no, there needs to be a space where people can just share patches and do whatever they want.
Yeah.
And it was cool that there's one that we don't even have any control over that now is pretty popular for doing that.
And if you tried to make your own and this other one was more popular, then people would get confused as to where they go.
Yeah, and it gets confusing. And,
So
it's fine for now.
Yeah. Because this other one would have happened anyway, because it's all open source, and so it's like
right. It would have, yeah. So we do have the one where we still maintain ours, where we have the patches that we've made ourselves, just because we kind of we officially if someone gets the Organelle who's not into patching it themselves or not interested in experimenting with even downloading patches, we still have to kind of back the ones that are on the device and able to answer questions about them and support them. So that's why we maintain this one factory repository where we have, those are the officially supported patches for the Organelle.
So one thing you mentioned earlier, which was something I've been interested in, because actually the music that I'm using for the podcast is sort of AI generated. It's a deep neural net kind of generated music. It's called Juke Deck.
Oh, cool.
It is kind of cool. But so you were talking about like AI and that kind of stuff. Is that something that you're thinking about or interested in, or just kind of is cool right now?
It's just cool. It is cool right now. But it's always been like, getting back to the cellular automata stuff, it's always been pretty cool idea of getting the machine to generate weird stuff for you.
Yeah.
And then when you're able to, it's gotten to a point now where you can pretty easily start playing around with this stuff. So I've been trying to get my feet wet with it in my spare time, but the the idea of being able to train the machine on, you know, sets of information and have it kind of regurgitate stuff is just like a really crazy and awesome thing to play around with.
It is pretty crazy because there's a few different companies out there that are doing it, and it's like they're good. they are really. It's impressive what they're able to do, and I'm sure there are different types of, you know, there's different types of neural nets out there and different types of heuristic learning, and there's different types of, you know, algorithms and how all that fits together. I'm sure that it's not just like, okay, here's this neural net. There's got to be rules based stuff, but like the Juke Deck stuff, I listen to. I'm like, it's better than any of the other free music that I could get. I feel like I should play some for you because it's like really impressive sound, and like it sounds like a band did it. Like it's got like regular like ukuleles and claps and stuff.
Yeah, I think it's just like the speech stuff we were talking about. You know, synthesizing people's voices, saying things that they didn't say.
Yeah,
I think it's right on the cusp of just, you know, music will be synthesized and we won't even be able to tell the difference. And people, I bet you can always tell the difference, but, you know, I say that, but I'm like, well, but also it doesn't really matter because it you know, people will always be able to tell the difference between, you know, what's a cool thing and what's a meaningful thing, at least to them.
Right.
It might not matter if it's generated by a AI or not. Someone pressed a button. Someone programmed trained the AI, right, and someone hit the button.
And someone chose to keep that one or throw it away.
Yeah, someone chose to keep that one or throw it away. Someone chose the training set, you know.
Yeah.
So it's sort of like I don't know, that question is... I'm talking about a question you didn't really ask, just because the question that always comes up with it, you know, it's like, oh, you know, this is terrible. The AI will replace but I think it's a very interesting kind of time to be.
Yeah,
these questions will come up with a kind of new reverence, I think, now that the AI is getting so insane.
Well, for what I was doing, I was looking for music, and then I had heard about this site, and there are other ones that you could do, but I was looking for music that worked for what I was doing because I wanted it to be a certain length, and I wanted to have like a crescendo at a certain point, and I couldn't find music like that. No matter how hard I looked in the kind of free license or cheap license music, I couldn't find what I wanted. Mm-hmm. And so I would have had to like hire a composer. And I think if I was, that I could have done that, and had I wanted to go that route, that would have been somebody's job that they would then have some money to be able to do their composing work. But it's a lot of money to hire somebody who could actually do something to the quality that I wanted, whereas this was actually like literally free with attribution. So all I have to do is at the end of the podcast say our music was provided by jukedeck.com, and then that's like I get free music that mm-hmm. is kind of perfect for what I need. And it's like, wait, so did I just take somebody's job, or are these people who program this thing now the new musicians in a way? Like the people who programmed Juke Deck, they have jobs. So it's like, I don't know. What is the moral quandary about that? Like, I don't know. It's weird because I think there's still going to be musicians. And actually there's a musician right now that it made an album that was all based on algorithmically generated music. Right. I forget what her name is. I should look that up. But she actually just put out an album like a month ago that is all algorithmically generated. And she wrote the lyrics and everything and sang and did the...
But it's performed. The music is played on instruments after it was generated, or the sound itself is generated?
Just a little bit of both. Mm-hmm. I gotta look it up. All right, I'll figure that out. But just the idea that now people who don't have a musical background like me can have music that fits exactly what they wanted. and it's really good quality. It's almost like beautiful that somebody was able to program this system that can do this stuff without a person. And it's the Juke deck actually has like an open API so that you could actually, like, if you wanted to, you could probably program an organelle to access that API.
Right. And just
kind of like, as opposed to going to a website, you could just do it on the organelle. So, I mean, that's one of the great things about the organelle is that it kind of can do anything if you were to program it.
Yeah. Yeah, we tried trying to get into the kind of weird stuff. I had it like sending Twitter messages out and stuff like that, which is some funny stuff. Because you can actually, you can post to Twitter with sound clip or something. So you can play some sound and then post it, hit a button and it like shoots it up on Twitter.
That makes a lot of sense.
If you were so inclined.
Yeah.
It makes a lot of sense.
Do people do that? Do you know?
I don't No. I'm just doing it for fun.
Oh.
I didn't make a patch. I was going to make it into a patch, but it's just kind of like, it's not really that hard. You just have to put like your Twitter key or password or something on there somewhere in the patch, and then it'll and it has to be connected, to the network too. Yeah. But the organelle is Wi-Fi, so you can do that pretty easily. And but also grabbing, connecting to the cloud and getting AI generated music. Yeah, I don't know. I don't see a problem with that.
Yeah, it's. I mean, there's so much stuff out there that is kind of open, and like it's kind of a great time to be in music too. Like, I think in some ways, music has made real changes. That now, like, electronic dance music and stuff sounds absolutely nothing like anything that anybody had heard 10 years ago. Not to say it's better or worse, but like, you hear certain, like, dubstep as the kind of goofy example, but there's stuff that just the sounds of it are totally new and different and like kind of unique. Is that something, like, did you expect that music would take the kind of weird electric turn that it has taken, or is that just something that you've been along for the ride?
Yeah, I guess it is kind of surprising when I think about it in those terms, because I was always just making, the electronic music was always just what I was doing. Yeah. But it's also very, very different from the kind of music that people are making more popularly, EDM and, these kinds of sounds. So it is crazy to think about these, just like, the dumb bro step, just guys like, playing around with like granular synthesizers and FM synthesizers and all this stuff, that was kind of like sort of in a more academic realm. Yeah. 20 years ago or whatever. So it is pretty trippy, but at the same time, it is kind of like obvious that would happen, because it's just like those sounds are so, like the sounds are sort of did what the AI is doing on a musical level. These software programs kind of did on an instrument level. You didn't need a group of musicians anymore, right, to realize a track. You just needed a laptop and like, a program like Ableton, to make a whole song, right. Well, with the computer, it's just like, that's obviously going to happen. But it has been crazy to like, you listen to the actual sound. Yeah. You're like, wow, this is happening. This is really happening.
Yeah. Well, I mean, I don't know as much as you about FM synthesizers and things like that, but you when you hear how they created that music, they did take really rudimentary sounds, or I don't know about everybody, but a lot of musicians take really rudimentary sounds and then build it up into this kind of soundscape that is just crazy and incredible. I'm trying to think of, I wish I had just listened to Song Exploder. Do you know that podcast?
Oh, yes. I do know that podcast.
It's like, it's a podcast where they take a song and they deconstruct it and talk about how like it came to be, and take every part, and actually they take the tracks apart, so you just hear like the bass and you just hear the piano part or something, and then they just say, oh, here's why I made the piano part that way, here's why,
yeah,
and it was this kind of crazy FM synthesizer that made me think of this. John Hopkins, the John Hopkins episode of that podcast, he's a electronic musician, but he's also a pianist.
Mm-hmm.
And he just makes these very like ethereal. I mean, in the episode he was talking about like taking mushrooms and how that influenced his stuff. So it was very like dreamy and ethereal. But the way that he built up sound was very cool. Like where he's like, okay, it started with this like very simple synthesizer, and then he just messed it up really bad, like really like messed with the sound to make this very ugly sound, and then put that in the background to create a soundscape, and then built a bunch of stuff over top of it. Yeah,
right.
So it's kind of, I'm talking a lot, but like just the idea of how musicians actually take these tools and create something awesome out of it. Have you worked with musicians much to like make that kind of stuff happen? You sort of work at the computer making the patches, but have you been sort of face-to-face producing at all to make that kind of stuff? No, not really.
You know, we kind of work with musicians a little bit, but you know, everyone has their own language and their own kind of way of working.
Yeah.
That in a way it's just like, you know, unless you're making music with them, it's kind of hard to kind of, maybe it's just challenging to kind of get in there. And I remember with the organelle early, we were like, oh, we're going to work with like musicians, and maybe once a month we'll like work with a musician and build a patch for them.
Yeah. And,
you know, everyone, and then we started trying to do that a little bit, but realizing that everyone kind of approaches the instrument differently. They approach every instrument differently, and the way of, you know, that they make songs and the way they make tracks, you know, it's like a very personal kind of experience. So it's kind of like, to do this, you have to really get on their level. And, you know, I think this is why when people make music together, they often do that for a long time, because it probably takes a while to really get to know someone musically and their processes, especially if those processes are intricate and complicated. So it was sort of, you know, ended up being easier to just say, screw that. We're just going to make them, you know, by our processes.
Yeah.
And we have a lot of experience making them because we've been making patches, you know, even before the organelle, you know, on different systems for our whole, you know, the whole time we've been doing this. So we're just going to keep doing what we do and make these things. But more, I mean, recently I've been trying to think about how these things really fit together in kind of a bigger musical kind of level, you know, a multi-layer kind of level. Mm-hmm. The instruments have been very kind of singular in terms of the sound. You know, they're kind of this one sound. And the organelle, we had this possibility to make, you know, multi-layered kind of things happening, because you can program it to do whatever you want. So you could have it program it to do 5 different instruments. But the patches we've always made have still been mostly single layer kind of instrument patches. And I think that's still the way I like it, but I've been trying to think of a way to build the organelle out into a more orchestral kind of like scenario, you know, where you're actually, you know, putting these pieces together on a bigger level.
Yeah.
And getting excited about doing that, but not doing it inside the organelle, but doing it with many organelles. So not like with building an organelle patch, but building this kind of framework for many organelles kind of working together.
Yeah.
And it's just a matter of the organelle we want to build is, you know, would have a speaker and kind of sort of more like the Kaleidoloop, so it can generate its own sound. And then we can have them kind of all over the room doing their thing, which is kind of step one, to spatialize the instrument, you know, make it into an actual sound source itself.
Yeah.
And then step 2 is make these pieces a little bit aware that they're part of something bigger. And, you know, the most trivial way of doing that is having them remember, you know, what they're doing. So I just imagine setting up these things, this sound, and say, okay, like everyone being all the organelles.
Right.
You know, so the organelle is kind of, it's become less of the musical instrument itself, but and more of like a musical mind. Like it's like a musician plus the instrument.
Yeah.
It's an actual. It's like, and a lot of the patches are already doing that. They're choosing the notes to play with some input. You kind of shove them along a little bit.
Right.
But then they play them themselves. I mean, the simplest example is like an arpeggiator where you just hold down the keys and it plays itself.
Right.
But we have, these generative patches where you just turn them on and they start making sound, right?
Yeah.
So it's gone from being an instrument where you're just hitting a button and getting a sound out, an instrument that requires a human to play, to an instrument that's kind of coupled with its own musical mind. So anyway, so you get a bunch of these musical minds and get them around the room, and then you conduct them, So that's the next step, is to build a system by which you can conduct these instruments. And we have some of the pieces working. We have this cool thing, which is actually, you asked about interfacing with Ableton and programs like that earlier, and they invented this cool wireless program or protocol which enables any instrument on a Wi-Fi network to synchronize their tempos.
Oh.
And it works really, really well.
Yeah.
And we built that into the organelle. I mean, it's just a PD object that someone wrote that works. And so any organelle patch that has an idea of tempo, arpeggiator or sequencer or generative thing, we can just add this functionality, and then every organelle in the room that's attached to the network will be synchronized. You know? So that's one of the components. Having these instruments be kind of temporally aware.
So you could have different people playing different instruments, or you could just have them.
You could have them play on their own. Yeah. I mean, people could be playing them and playing sequencers or arpeggiators, and those will all be on the same clock. Yeah. It works great. It was originally, I think, made for apps. So it's built into like most iPhone apps.
Oh, okay.
Or like little beat generators or sequencers.
So
iPhone apps, so people can have their. You can have one running one, I'll running one, and then we have Ableton running on that machine. And how do we synchronize them all, which was the problem. Yeah. And so they made this thing so it synchronizes them all if they're all on the same network. Huh. So that's cool. But then, how do you start and stop them? I think they actually just added like start and stop, kind of the idea of start and stop to this. Mm-hmm. But also, you want to be able to exchange more information. So, I don't know, starting to think about like, how do you put together a song? And this might be where it kind of gets interesting, Yeah. Sort of you'd be like, stop playing, or you keep doing that. Like, I like doing that. I like what you hear. So there's a basic mechanism there, like you're kind of curating this sound. Right. So you could maybe, if something's happening that sounds cool, you could say, okay, everyone remember what you're doing.
Right. I'm sorry, I'm looking something up because
so that's sort of step 2 is to figure out a way to conduct these instruments.
Yeah, I mean there are people who kind of do that have interfaces that almost look like conducting, where it's like a glove that will have some kind of I actually know somebody who does that, but know someone tangentially. We did a hackathon together. And I will get his name and put it in the show notes because I will figure that out. But that there are people who actually make a performance out of that kind of conducting digital instrument, and then to hook that up to the organelle becomes like another now you're conducting actual instruments, almost like a orchestra. Yeah, that's very cool. I think he had this thing where there was like a proximity sensor that he also had.
I think you were telling me about this at one point, possibly.
I'll get you his name.
Cool.
Yeah, I mean, so I guess we talked a lot about what's next. Like, do you see other instruments being next, or because the organelle in a way is like this real incredible machine that can do 10 million things, so it's hard to get to the next step on it. So what would the next step look like?
Yeah, it has been a little bit of a challenge because we mostly after making the organelle, we got really into making patches for it. And kind of distracted by it in a way. So we were working on a bunch of stuff. I can't really talk specifically about what we're having in the works.
Oh, that's okay. Yeah.
But I mean, the big idea, for me, is what I really just mentioned. This idea of putting them together in a bigger kind of arena, a bigger orchestra, an orchestra of organelles.
Yeah.
And I think there's some interesting, interesting problems to think about and solve there.
Right.
That might lead to some cool new devices or whatever. But the organelle, it's a challenge because it does, especially now with a lot of patches, you can't really change the hardware up too much.
Yeah.
We're always like, oh, I wish there's another knob, or I wish there's so if you make a new version that, you have to ask carefully, is this going to be backwards compatible with all these other patches, or is this going to break it? Right. So this is a constant question that became, I think when we first came out with it, we didn't really anticipate, the complexities there. Yeah. But at the same time, just keep making cool stuff, I think is it's what we have to do.
Totally. Well, I think that's the best place to probably stop. Just making cool stuff. That's excellent. Right. Yeah. All right. Thank you, Owen. That was a lot of fun.
Thanks a lot.
I like sitting down and talking, so thanks. That's our show. I'd like to thank our guest, Owen Osborn, for joining us. You can find Owen at critterandguitari.com and on Twitter at critterguitari. Guitari is spelled Guitari. I'd like to thank our sponsor, Green Lane Design. Remember to mention the Good Data podcast to get that free assessment. That helps everybody. Our music is algorithmically created by Juke Deck, which is pretty amazing. Try it yourself. Visit jukedeck.com. For Good Data, I'm Drew Farnsworth. Talk to you next time on the podcast.